All right, so I'm Brian Demers. I'm a developer advocate at Gradle. So I spend a lot of my time talking about testing and build tools and all those things.
So I'm François Martin. I'm a senior full stack software engineer at Karakun. I live in Switzerland, and we also have an office in Germany, of course, if somebody of you is interested in Dortmund. I'm also at the Swiss Testing Board. And that's how you can find me here.
Yeah, so together we have 30 years of 30 years of experience of rerunning tests. Okay, so let's start with a big statistic, right? So we estimate that $36 billion every year is spent on developers rerunning tests. So that's just time waited while we wait for our test to rerun. Okay, so to put this number in perspective, because 36 billion is insane, and yes, this is USD, but it's about the same for euros. So 40 billion every year is what it would take to end world hunger by 2030. All right, so that's wild if you think about it, right? We are literally wasting the amount of time it would take to end world hunger, right? Obviously, it's not the same dollars, but it's something we really should think about. And these numbers are just too large for us to comprehend.
So now to look at the topics that we will cover today. So on the one hand, we will look at what is a flaky test. We will tell you a little bit about how you can find them, how you can deal with them, and lastly, how you can fix them as well. So now to get to the question of what is a flaky test, and I can definitely tell you it's definitely not fake news. So looking at the definition of flaky tests, so a flaky test is a test that exhibits both a passing and a failing test results when you run a test with the same code multiple times. You probably experienced this for sure. I mean, who of you experienced that before? Raise your hand. Okay, not enough of you people. Maybe some of you, were just too lazy to raise your hands. You were thinking the others already did. No, it's fine. Yeah, so actually, doing something multiple times is usually multiple times and expecting a different result is usually considered to be madness. But in software engineering, it's called flaky tests. So now let's look at some of the examples of how flaky tests happen. So some of the flaky tests are caused by timing issues. So for example, if you have an end-to-end test where you have a search term that you enter into a text box, and then you click on the button search, then some of the tests you see, then they just wait for 1 second, and then they click on the result that you get. And the red part that you see now is where the flakiness gets introduced. It's really exactly in this waiting for 1 second. What happens if, for example, the server is slow for once and it takes 2 seconds or 3 seconds or 5 seconds? Then maybe what some of you tended to do was just increase the timeout to 2, 3, 5 seconds, and then sometimes maybe 30 seconds.
I've done that, yeah.
Yeah, raise your hands if you did that. I also did that as well, for sure. And you keep increasing it, and then sometimes you end up with 30 seconds, and it's still not enough. And you try to live with it because waiting for even longer wouldn't be really an option. That's way too slow. Of course, this would make our tests unbearable if we had to wait for such a long time all the time to prevent flaky tests. So here it makes much more sense to wait specifically for something to happen, like for example the search results to appear. And in this case, then you can do the click. This will be faster as well. And you just define a timeout, and this should be done. Then another one is test data related. So if you look at some examples here, let's say you have an input field and you have a prename which doesn't allow you to enter any special characters. Then there are some tools with which you can randomly generate prenames, for example, to use in tests. There was also a presentation today by Elias that covered this. And maybe some prenames that are generated contain special characters. My name is a prime example of this. And in this case, the test will fail and it will look flaky to you because, of course, you ran this test 10 times before and it was running fine. Why suddenly is it failing? And then you find out, that's the reason. And then also, if you have a test that is reliant on predefined test data that you have in the database, So, for example, you can have dependencies between tests. So let's say you have test A, and that test A performs some actions, and test B actually requires those actions to be executed successfully from test A. Then this means you always need to execute test A before you execute test B. So then, if you run the test A, if you don't run test A and you simply just run test B, and you forget that you need to run test A first, then it could be that the test is failing. Also, if let's say test A fails midway, this means that test B will fail as well, even though maybe if test A would have passed, test B would have passed as well, which is obviously also not great. Another thing are failing tests cause inconsistencies, and so the thing is, if you have an action in a test where you change data in the database, but it fails at a later step, then when you run the same test again, then it already fails in the beginning, because it could be that it requires this data to be in a certain state, which wasn't cleaned up, for example, when the test was run. Then there are infrastructure-related issues that you could have that result in flaky tests. Mostly this is down to having unstable infrastructure, and this results in the tests timing out mostly. This is how you can notice this from happening. And this is one of the most difficult things to reproduce, actually, which makes this really difficult to troubleshoot and fix. And to give you some examples, the build runners are, for example, under heavy load, and then suddenly, the timeout is not long enough, and then the test will fail, for example. Or also, if you have microservices, for example, and then one microservice calls another microservice, and this other microservice is under heavy load, then it could be that, for example, the server doesn't respond as quickly, which will again lead in a timeout, and then leading the test to fail. Then we also have resource contention related issues. So this is something that you mostly experience when you run tests in parallel. And for example, if you have multiple tests that are trying to write to the same file at the same time, then you can run into issues with file lock, or also you can run into concurrent modification errors. Or if you have multiple tests that are trying to create a user with the same username at the same time, then of course this could result in unique constraint violations, for example.
All right, so why do I need to care about flaky tests?
Yeah, that's a good question. So let me show you. Rerunning tests waste quite a lot of time, as probably any one of you that experienced this can imagine or can also say, and I saw some nods, so that's great, thank you. And also you need to invest repetitive investigation efforts to determine if the test is really flaky, or if it's, if it's just, failure of a test that is indeed legitimate. And also, one thing that is really bad is that your team starts losing trust in the test results, and this is very important to have trust in the test results, as we test to improve the quality of software, and if we can't test the results, then the quality will also go down, which is also not good, of course. And also, by the way, I have a good example that happened to me at a different project, where rerunning tests was wasting a lot more time than it did before. We did an update. I'm not sure. I think it was an update of some kind of version, of a dependency. And then suddenly our tests were beginning to be crazy flaky. They were already very flaky before, I have to say. We didn't get much time to fix them, unfortunately. But it was kind of at the point before that was manageable, but it got to an extreme point where you had to rerun tests about 8 times, which may sound already quite bad, but it gets even worse when I tell you that each of those builds took 1 hour to complete. So you can imagine it wasn't that small of a development team either. So you were, kind of sometimes fighting 1 week just to merge your change, because constantly would have to rebase your change on top of the other things, and then you needed to run the tests again, and yeah. So it was really just a matter of luck. Another thing that is not directly related to flaky tests, but pilots were frequently ignoring an alarm in a cockpit of a Boeing 737. Well, not just in one, actually in a lot of them, they were just ignoring a specific kind of alarm that they were getting. And this resulted eventually in a fatal plane crash in 2005, which was really severe. And this can show what ignoring those warning signs, like for example flaky tests, can show us.
All right, so let's talk a little bit about unit tests and integration tests. All right, so raise your hand if you have a unit test that connects to a database, a REST API, or some other external service. Okay, some of you are truthful, some of you are lying to me. Right? I know, I don't want to raise my hand for that either. I know better, right? But if your unit test connects to some service like that, it's an integration test. If you want to call it a unit test, I won't tell anybody. But in the sake of this conversation, it's an integration test. Okay, so we've all seen some variation of the testing pyramid, right? Everybody? Okay, most of us. All right. So it always looks something like this, right? So you have unit test at the bottom. That's the foundation of our testing. We have a lot of unit tests. Hopefully they're quick running. Then as we go up the stack, we have integration tests. Those probably take a little bit longer to run, but we have fewer of them. And then at the top, maybe we have end-to-end tests. Okay, and those probably take a lot longer. We're going to orchestrate a browser, right? You're going to start up your browser. Hopefully you have whatever Selenium driver or whatever it is you're using. You could click buttons, wait for that network request to happen. They just take a lot longer. All right. But there's some variations to this. Sometimes there's component tests and some other layers, but you get the idea where I'm going here. So I want to flip this around and think about it from the other direction, right? So we have unit tests on the top. Hopefully those are pretty stable tests. Unless you're doing some multi-threaded stuff in your unit test. Your unit test might be a little more stable than, say, your integration test. Right? Again, those integration tests have database connections. They're waiting for servers to start. Whatever it is, there's a little more volatility there. And then again, as we go down, we have our end-to-end tests. And I mentioned you have a browser. So I've had tests fail because I didn't have Firefox installed, right? And my test expected to drive Firefox, and so I had to go do that, right? And then there's a whole bunch of stuff to happen. There's network requests from the browser. There could be a proxy involved. There's just more stuff in the way, right? So there's a lot more potential for flakiness as we go down. So we can think about this too as kind of a continuum, right? So unit test over on the right here. Am I right? The left? No, the right.
On the left.
Which one is it?
Left.
This side. And then as we move this way, our tests become more flaky, or the potential for our tests become more flaky. Okay. So I know folks that prefer to write integration tests instead of unit tests. Anybody? Oh yeah. Okay, I'm talking about you. Usually the idea is, it's fewer lines of code to write to get more coverage. They're a little easier. They're high level. Think about these bulk tasks, but that's not the full story, right? They take longer to run. You're introducing external systems likely, so there's again more volatility, or you have to add mechanisms to make them fault tolerant. Okay, so at a previous job, I was working on an API client, right? So just a glorified REST wrapper. It was a pretty cool project. It had caching. Caching at the request level, delta tracking between requests, so you could do patch requests for updates, for some forward compatibility support. It was really neat, but one of the decisions the team made as a whole team is we were going to run our integration test against a live server. Okay, so that created a few problems. The main reason for this is we didn't trust that the server wouldn't change, right? That's a different team. They had different requirements than we did, and we didn't trust them. So we're like, well, we're going to test against a live server and make sure that you're working with us and we're working with you. Okay, so this created a whole bunch of problems. I don't know where my mouse is. It's all right. So this created a whole bunch of problems, right? So the tests were flaky. Of course, that's why I'm talking about it today. But think about all of the stuff that has to be on my laptop in order to make that work. Right, so I have to have a connection to some server. I have to know the URL. I probably have to authenticate. Right, so now I have credentials on my laptop and in CI. And if the credentials get rotated, it doesn't work anymore. If multiple people were running the test at the same time, we hit rate limiting issues. The numbers just compounded, right? Some of the tests didn't clean them up after themselves. So I'd add a bunch of resources, and then some later tests would get the resources. So there'd be giant collections we'd have to go through, which slowed performance. In IDs, so again, if multiple tests were running at the same time or running after another, sometimes they were using the same IDs. So we had to spend a bunch of time trying to make sure all of the IDs were generated and not going to overlap. It was a pain, right? I think we could have reduced the complexity significantly if we just would have mocked the server, right? We said, look, server team, you need to make sure that these APIs do not change, that they're in this format that we agreed on. And then we would do the same, and then assuming everybody's happy, their test would have been a lot easier to deal with. Now, in hindsight, I understand why the team, why we did that, and I don't necessarily think it was bad for the team, given kind of the political will we had. But given what I know now, I definitely would have pushed a lot harder to try to fix those problems then, instead of waiting years to fix them.
Great, so let's talk about how you can find those flaky tests. And the question is, who are you going to call? Flake busters. Oh.
We did eventually. We defined like open API specs, and everyone sort of adhered to those, so we got rid of that problem.
The question was, by the way, if they used any other testing types. So.
Yes. Sorry, I should have repeated that. Thank you.
Yeah, no problem.
Yes. Like there has to be a rigid. We would need to trust the API, so we would need to define rigid guidelines as to what these messages look like, and we would need to be able to trust that both ends of that, the server and the client, would adhere to that.
But thanks for the question. So now let's talk about running tests in parallel. So doing this can reveal actually quite a lot of issues that we mentioned before. Like, for example, the resource contention, and also your dependency on test data gets revealed like this quite easily. And also your dependency on a test execution order. Like, for example, as I mentioned, if you need to run test A before test B, you will notice this pretty quickly when you run them in parallel. And as a side benefit, your tests will execute faster. And I never heard somebody complain about the fast build, so yeah. And here are some technologies that you can use to run tests in parallel. These are not all of them. WebDriver IO, for example, runs tests in parallel by default, and Cypress does it, but only in the cloud and only the paid option. And for JUnit and Gradle, you can do it through configuration. And after you downloaded the slides, you can see those are actually links that you can click on, and there you can see how you can use it.
Awesome. All right, so this QR code will get you a link to where you can get the slides if you want them. We'll have this again at the end. All right, so most of the techniques revolving around detecting flaky tests all have to generally do with rerunning the tests, right? So any Maven folks in here? Okay, a few of us? Yeah, Gradle folks? Okay, so they all kind of work the same way. This is a Maven example. The Gradle has a test retry plugin that works very similar to this. So basically, this first parameter is called rerun failing test count, right? We just add words to our parameters and make them long. I've set the value to 3 here. So what's going to happen is my test is going to run up to 3 times. So it has 3 chances to pass. Right, so if it runs and then fails, it's going to rerun. If it fails, it's going to rerun. If it passes, that test passed. Right, that's not great. 1 out of 3 is not great, but that would be a passing test. Okay, so setting up your build this way is great, but it has some pros and cons. Right, so it's going to let your flaky tests get through your CI system. It's not going to slow down your developers, which is good. Right, you don't want your job to be slowed down by a flaky test that you didn't even touch. But again, we're just kind of kicking the can down the road or sweeping this problem under the rug, and it's really something that we need to pay attention to. So there's another option, the second line, fail on flake count. If you set that to a number greater than 0, if one of my 3 tests fail, right? If it's a 1, if one of them fail, I'm going to mark the test as I'm going to mark the build as a failure, right? So you may want to do that. That has the provided benefit of saying the test passed, but it was also flaky, and we don't allow that. Okay, so in general, I think this this type of detection is beneficial. I think you should do something like this, but you can't ignore those flaky tests. You need to at least track them and record them. So don't abuse this technique. All right, there's one gotcha I want to point out. We talked about timeouts a few minutes ago. Anyone have tests that time out? A few of us, yeah. So if you have a test that times out, let's just give it the number of 30. Right? And you're going to retry that test 3 times before it fails. Now your 30-second timeout becomes 90 seconds, right? And if you have 1,000 tests, well, that's a lot more time than you thought. So you have to watch out for, if you're using the retry technique, if you have some tests that can just hang, you may want to change the behavior so they can't just hang for 30 seconds and then, you know, somebody emails you in the middle of the night, your build is still running. What's going on here? All right, so anyone ever submit a pull request to a CI? Yeah, everybody, right? Wait, there's a caveat. That there was a test that failed that had nothing to do with your change. Okay, so that's a flaky test, right? Somebody else's thing changed that had nothing to do with your code change, right? So now we've shown you how to kind of detect these flaky tests. You also need to track them. So this is the Spring Teams instance of Develocity. So this is basically a dashboard that shows a flaky test. This test is the sample Jetty application test. It's again, we just chain words together here. The yellow shows the flaky tests that are run. The green is passing and the red is failing. So somebody should probably take a look at this test, right? This is their most flaky test in the Spring builds. Okay, so now that we know how to find them, we should talk about what we should do with them.
Perfect, thank you. So now we talk about how we can deal with those flaky tests, and how we do that, we just deal with it. So let's talk about prevention, which in my opinion is probably the most effective measure that there is, as preventing them from being introduced in the first place. Doesn't means they won't exist, and this will means you will have a great time. So one suggestion I have is, if you have, for example, a pull or merge request, try to run new or change tests, for example, 3, 5, 10, 50, maybe even 1,000 times, depending, of course, on your resources and on the test type. Of course, if you have an end-to-end test that takes 1 minute to run, then running it 1,000 times will take 1,000 minutes. If you work at Google and you have a supercomputer where you can run the tests on, maybe that's fine, but usually probably not. And alternatively, you can also run all of the tests multiple times nightly, and this way, if one of the tests is flaky, there is a high chance you will find them. I think this is something that should be able to really find most of the issues that you have. And also this makes sure that you get very quick feedback this way, because you get feedback instantly when you create a merge request, and also the person that usually developed something knows best how to fix it or what could be flaky about it. And since that person notices it instantly and can make changes, this is usually quite beneficial.
All right, so we've talked about this a bit already, right? But you want to make sure anytime you find there's a flaky test, that information is communicated with your team, right? So most of the time we kind of assume that if there's there must be a test problem, right? But that might not always be the case. You don't want to waste your team's time. Anyone, again, everyone who raised their hand a minute ago when I asked this question, anyone ever spent time digging into that failed test that you were sure it wasn't your fault? Yeah, that's more people raise their hand now than before, right? So think about all of that time wasted, right? So again, what is it, 26 billion? $36 billion.
36, yeah.
Every year, right? That's exactly what we're talking about. You're wasting your time, you're wasting everyone else's time. You also don't want your teammates to be mashing the CI retry button, right? If anyone have CI queuing issues? Yeah, I know you do. Okay, so if you have CI queuing issues, right, this is just going to exacerbate that problem. So let them know. Tell them there's a new flaky test found, whatever it is. Send an email, Slack, whatever it is, your notification mechanism. Tell them what's going to be done about it. If you're going to quarantine the test, if a fix is going in soon, whatever it is, let your team know. You don't want to make them waste their time while they're trying to work on the features that they're trying to get done.
All right, so one technique that we introduced at a project that I was working on was we said that every time you start a new sprint, what you would do first is you would first fix a flaky test, and only after you did that, you would pull a new issue. And this worked really well, I have to say. I mean, you can imagine one test per sprint doesn't sound like a huge deal, but you have to remember that every developer does one of these, and you can imagine if you do this regularly every sprint, you will pretty quickly get rid of all of your flaky tests, and it's usually quite easy to get management buy-in here, because it's just one flaky test that you fix every beginning of the sprint. I think most of you should be able to convince your management to invest time in this.
All right, so if your management is on board, you can do what we do, and we call them flaky test days. So it's the same idea, except at the end of a release, if there was a bunch of flaky tests found, so the Gradle build tool team and the Develocity team both use this technique, they all get together, virtually, and they find a list of our flaky tests, and they go down them from the top to bottom, right? So this does two things for the team. It stabilizes our code base, which, that's the benefit all by itself. But the second benefit for either one of these techniques is that it teaches your team that flaky tests are not a good behavior.
So one of the measures you can take, which Brian already touched on earlier, is to quarantine your tests. So I really recommend you to quarantine your test after the first failure already. If the test cannot be fixed in a timely fashion, then this means that there is an impact on the productivity for all developers. So it really should be quarantined to stop that, in my opinion. And you really need to remember to fix the quarantine tests timely, because it can get lost pretty easily if you have a test that is quarantined. And also, one technique you can use is to set a limit for the tests in the quarantine. So for example, you say that you can have no more than 5 tests that are in quarantine. And if there are more, then you need to fix the existing tests before you move on and then create some more new tests. So before you then quarantine some more new tests, sorry. You will see this in a second. But thanks for the question. Also, you can define a time limit for quarantined tests. So for example, you can say that you can only have a test quarantined, for example, for 3 months, and then at this point you need to fix it later. So yeah, to answer the question that was asked earlier, so quarantining a test is essentially you disable it and you add a reason to it. So here, for example, you can see on the top a way on how you can do this with JUnit. And you can see you can put on top of the add test annotation, you'd simply put add disabled. And then you can put a reason there, or I really recommend you to prefix this with something like quarantine : and then this also makes it very easy for you to search through your code base, to find all of the tests that are quarantined in this way. And you can also then put a reason or a link after it, or I really recommend you to do this. If you use an issue tracker, just put a link there, and then you can this way a little bit track them easier. And in Jest there is something very similar, except that you need to do it.skip instead of being able to do the add disabled thing. And there's unfortunately another way to add a text specifically to it, but you can, for example, also just put a comment there and then also again prefix it with quarantine : and then this way you can quarantine them.
All right, who has tests that are commented out or disabled in their code base? Wow, that's way more than I was expecting. All right, so in a perfect world, we're going to fix all those tests, right? And it actually pains me to suggest this, right? But if you have a test that's constantly failing builds, you should consider deleting it, right? If it's not providing value, it's not sparking joy, you should get rid of it. Right, so leaving a test disabled or commented out in your code base for too long is going to create confusion, right? So everyone here apparently has this problem. So in a couple months, you're going to come back to this disabled test. You're going to say, I don't know why this was disabled. Let me try to run it. Maybe it works now. So you delete the annotation. It passes. Well, I'm going to check that thing in, right? And then now your flaky test is back in. or it was commented out and you have the same problem, or maybe that test is no longer a valid path anymore because something changed and this test has been commented out for a while, right? Hopefully everyone's writing comments in their code in general, right? Everybody who's commented out code, you know exactly why that test was disabled? Nobody? Okay, one guy. A couple of people. Okay, that's good. But again, I'm not advocating to getting rid of test here. Maybe rewrite that test in a different technique, right? So delete the test, rewrite it, or maybe you've already covered that path through some other way and you don't need that test. So think about this. All right. Anyone ever have a test that fails in CI only? It always runs locally? We all,
runs
right?
means passes,
Right,
by the way.
right. Yeah. So what I typically do is I make a bunch of small git commits and I push them to my pull request, you know, with like system.out.println or whatever other debugging techniques, and I spend hours trying to wait for those CI cycles to happen, and nothing gets done, right? One way to get around that, if your environment is conducive to this, is you can SSH into the CI agent, try to rerun the tests, try to connect a debugger, whatever it is to get more information instead of going through these really long cycles, right? Or maybe your CI team or your infrastructure team can provision you a machine that looks exactly like your CI infrastructure, so you can use that, right? So you're not actually messing with somebody's CI server. Again, this might not be possible everywhere, but if it is, you know, you might want to look into that option.
All right, so let's have a look at how you can defeat Murphy's Law and fix those flaky tests forever now. So one of them is, of course, if you are having a test data problem, then the easiest way to fix this is to get some consistency in your testing data. And here I can really recommend that you use, for example, in JUnit the feature that is at before each, where you can specify something that runs before each test that gets executed, and in after each something that gets executed after each test. And usually it makes sense to create some test data in before each, and then in the after each you delete this test data again. So this way you don't mess with anything. And also, by the way, in end-to-end tests, don't create test data on the UI, please. Please use an API where you make some calls to it, for example, or something similar to that. And this also helps you with making your tests less flaky, because of course you have less paths you need to go through to set up test data, which might fail in itself because of something that is flaky. Yeah, and there's the same thing you can do in Jest as well. You can see the syntax on the right in case you're interested in how you can do that, but it works in the same kind of way. Another option is to use test containers. There was actually a talk about test containers that was earlier today. And here I just put in a little snippet of how it could look like. So by just adding those lines that you see here, it will automatically start and stop a PostgreSQL container with every test that you run. And this way you can also ensure test data consistency, because you spin up a database for each test, and this way you can really contain that in a very nice way.
All right, so we touched on a lot of this already, but I really think your tests should be isolated, right? So even if you're not running your tests in parallel, which apparently nobody in this room is, you should be following good test practices, right? So what happens if the order of your tests run, and what happens if that changes, right? The system state may no longer be the same. Do your tests still pass, right? That's a simple question to ask, right? Can you run a single test method from your IDE? And can everybody do this? Or who has to run a whole class or a whole suite for their test to work from their IDE? A couple of us, right? You should avoid doing that. You should try to fix that, if nothing else, for the sake of productivity, right? If your test takes forever to run, and just the setting a breakpoint becomes a pain in the butt because, you want to pass through the first 10 times, but you want to catch it the 6th time or whatever it is. It's a pain. So I think you really want to focus on your tests need to be able to run isolated, not depend on other tests. So I had a test case recently where I was convinced I wrote the test correctly, right? I looked at it and I was like, this is a beautiful test. I wrote this code. It must be good, right? No, that's not quite the case, but the test would randomly fail, and I could not figure out why. It was an integration test. So come to find out, what was happening is I think my tests were running in parallel, but they ran in just the right order, where I had a test that was creating data, and then I had a test after that that was updating the data, right? So of course, if those things run in a different order, the update test fails because the create test didn't happen. So what I ended up fixing was my update test was now decoupled. My update test then created all of the objects it needed to do, right? So it was basically a couple lines copied from my create test. I created an object, and then I updated it, and then I made sure the updates were applied, as opposed to, overlapping my test. That way, each test runs in isolation. Okay, so I think, again, we touched on a few of these before, but you should avoid a bunch of things, reusing system settings in your tests. Okay, so number one is system properties. Anybody setting system properties? Not using them, but setting system properties? This guy's laughing. He knows exactly what I'm talking about. So this modifies the behavior of your test. If you're using feature flags or whatever it is, you could change your whole system, and the state of that system is changed. So if you're running them in parallel, they could get some undeterministic behavior, or even sequentially, you could end up causing a build down the road to fail. Anyone have tests that reuse the same file? Same output file? Yeah, same guy. I do too. I'm not picking on you. I have the same problems. A couple of us, right? Yeah, so that's another problem. So again, if your tests are running at the same time, they're going to reuse the same file. You're going to get lock issues. There's going to be some problems. Even if they're running sequentially, it becomes very difficult to debug your test after. Why did that test fail? Well, the output doesn't look like at all like what I expected. So you really should isolate your files. And the next one I think everyone runs into, right? You should be using a free ephemeral port if you're doing any server testing, right? Who has hard-coded tests with port 8080? Nobody's raising their hand? Ooh, it's a good crowd. Everyone's learned, maybe? Or maybe nobody wants to admit it.
So does anyone have a hard-coded test with port 8000?
Yeah, 8000.
Any other port?
Any other port? Nobody. Okay, good.
Cool. Nice.
Good
job.
So make sure you're using a random free port, because what happens is you can run tests multiple times, right? At the same time in parallel. But it also prevents a server that's running on your machine to prevent your tests from running. So port 8080, if I have a Tomcat instance running on my machine, and then my tests are also using port 80, the servers are not going to be the same as what I expected them to be.
All right, so in end-to-end tests, the first three strategies that I'm about to tell you, they are strategies you can use to contain the impact of flaky tests to the lowest attack surface possible. So one of them is to use deep links to navigate directly to the page that you are testing. This means that if there was any page in between that, for example, could cause any flakiness is already out of the equation, then you should start the test already with the test user logged in. This way, if the login doesn't work for some reason, and I'm sure most of you have experienced this before, then your tests will still work. And another one is you should try to make it possible to run each test spec independently, which means that if one of the tests is flaky, at least it's just one small test, hopefully. Again, as I mentioned earlier, do not wait in predefined time intervals. Make sure you wait for a condition with a timeout. And you should always use table test IDs and selectors. Don't, for example, select a div or something like that. If you change it to a span later, then you need to change your test, which is annoying and takes more time of you or causes the test to fail. And then one of them is also you should consider mocking external APIs. So you have to be a bit careful here. I wouldn't do this in every environment. If you have multiple environments available, then it really makes sense if you mock your external APIs in the earlier environments for sure. In the later stages, if you don't have any throttling, rate limiting, or page requests that you have to do to these external APIs, then I really recommend you to use the real API because this gives you a bigger coverage. Of course, this comes with more flakiness because if the service is down, then this means it will be flaky. But if you limit it to one environment, this shouldn't be too big of a problem. And also, you can do this or should do this in an integration test as well, by the way.
Okay, so what if we take those tests and reduce some of the flakiness, right? How would we do that? We can move them to right to left. Maybe we rewrite our end-to-end test as a bunch of unit tests, right? So hopefully this will speed up your build because your unit test should be much, much faster than your end-to-end tests. And of course, we're also going to improve the stability as we go the other way. So really, we would like to improve the stability of our code. Our tests are faster, we're more productive. It's a win-win all around. Okay, so again, I think flaky tests are kind of a cultural issue. And it's not that we're malicious about it. Like, oh, I really want to have flaky tests, right? Nobody says that, right? Nobody wants flaky tests, but we just deal with it, right? How many times you rerun the button and you're just like, oh, that's just what I do. I just rerun the button. And that becomes second nature, and we just do it, right? So we really need to push against this, but that requires more effort. So you need to educate your team, maybe hold brown bag lunches, make flaky tests more visible. If somebody has that data in front of them, it's really hard to fight against that, right? Track CI reruns, right? So if you can just know how many times on average builds are rerun before maybe a merge goes in, that could be powerful data to make this happen too. Or, again, make a business case for it, right? Developer time, compute time for whatever cloud coverage or cloud resources, rather. Show your manager that you're losing money. Maybe that's what helps move your needle. All right, so we have a few minutes for questions. So do we have any questions in the app or in the audience?
Yes, we have actually quite a few of them. And also, by the way, take your chance. On the left, you can see the slides.
Yes.
On the right, you can see the questions again. So scan whatever code you want. If you want to ask questions, the right one, of course. If you want to grab the slides, the left one, or both. So we have 6 questions, actually. So one person asks, finding flaky tests, is there an option to run tests in random order to find tests that depend on test execution order? So actually, sorry.
That's a good question. I think so, but I'm not sure of a specific way to do that. I know how you could do it programmatically, but I don't really want to suggest somebody writes a JUnit extension to modify the order of their tests.
I mean, actually, as if my memory serves me correctly, then JUnit already by default runs them in random order. It's more that I see some people forcing them to run in a certain order, and they don't notice that it's bad, maybe, for example. But it should be that JUnit runs it at least in random, but don't quote me on that. Check it, please, to make sure. But and a lot of other test frameworks do that as well. There is, of course, randomness is never truly random. So sometimes, it could be that coincidentally the same tests run in the same way. But yeah, but good question. Yeah, thank you. Another one is, do you know any self-hosted tools for monitoring and detecting flaky tests? And I think that's a good question.
Wow, that's a loaded question. So I have a Gradle booth over here. I could talk to you all day about that. So Develocity can actually track flaky tests. Basically, you set up your Maven build or Gradle build like I talked about, and that data gets pushed into a server, and then you get what I showed you for the Spring instance.
And you can also self-host it, right?
Yes, and it's going to be self-hosted. So come talk to us at the Gradle booth if you want to hear more.
Great, thank you. Also, great question. Finding, that's the same question I saw earlier, sorry. The negative of fast builds is less time for a coffee. That is very true. That's why you go to conferences and you get free coffee vouchers, so you can go drink a coffee, right?
Absolutely.
Should we delete flaky tests in order to fix them?
I think we covered that.
Yeah, I think you really have to pay attention to all of the steps that we mentioned. Don't just delete them as the first guess. Try the other options as well. I think deleting should be like a last resort option.
Absolutely, yeah. You don't want to just delete tests because you don't like them.
Yeah, absolutely. Definitely not if you don't like them.
But again, maybe rewrite them, try to fix them. If you fix one flaky test, often there's a cascade benefit that will fix other types of tests. Or you have this behavior that's been a copy and paste. So if you fix it once, you might know how to fix it other times.
So then one person asks, do we really need management buy-in for everything? I would say, it depends. If it's a lot of work, then yes. I mean, if you just have a flaky test you can fix in 1 hour, then go for it, fix it. You don't need to talk to your manager to, ask them if you get 1 hour of time. That would probably be also a waste of time. But that's how the world runs in a way.
Yeah, I also think it depends on your engineering team. Like if you're asking that question, you may or may not know the answer for your team. Like I've worked on teams where we absolutely didn't need buy-in. The engineering leaders understood that this was this was something we needed to do. I've also worked on teams where we had to kind of fight tooth and nail for those things. So again, that's kind of a cultural issue that needs to be addressed as well.
Absolutely, yeah, good point. Yeah, but also good question, thank you. Then let's see. They are a bit out of order. The question was, have you used OpenTelemetry or similar monitoring to determine the cause of test timeouts? I actually did, and this really helped me. So I can really recommend you to try the same. It usually is very useful to see, for example, if you have microservices and you see that one microservice makes a request to another, and then you see there's where the timeout happens because coincidentally the request just happens to be 30 seconds, for example, or something like that. Yeah, it's really useful for that.
All right, I think we've got time for one more.
Yeah,
make it a good one.
Let me see.
And we'll be here, so come down and talk to us afterwards, or meet us in the hallway. And
okay, so I'm picking this question. There's another one, but unhappy person, if you want, you can come after the talk and talk to us. Is there a plugin or method to enforce the limit of tests in quarantine? Actually, that's a very good question, because I remember when we were assembling the slides, I was researching this online because I never used one at work before, but I was thinking, there should be one, as maybe the person that asked this question was also wondering or thinking. Actually, there are, but from what I could find, they are not very well maintained, unfortunately. I mean, they are very simple in nature, so feel free to try them out. Google for them. There are a few of them. I just didn't have time to try them out, and I didn't want to recommend something to you that I don't know is battle tested or that works and works reliably. So yeah, feel free to try that out. That's a really good question. Thank you. And also thanks to everyone that asked questions. Sorry we don't have enough time. Feel free to come to us. Also, I have some Swiss chocolate that I brought with me. So if you're interested, come find me and I'll give you some. Thank you to everyone who joined.
Thanks, everyone.